Hey everybody, welcome to today's chemistry lesson. Today we're going to be talking a little bit about chemical reactions, which is again kind of the introduction to our new unit. We're going to be focusing just on identifying different types of chemical reactions today. And usually when I teach this lesson in person, I like to teach it in a love story. And so I will be kind of using that love story today, but I have used some Star Wars characters in place of my general love story characters, but just because I didn't want to have to draw all of these characters not in person. So if you do not want to have to sketch all these characters, I recommend just using my printed notes sheet for today. Or if you are sketching them out, you can always feel free to pause the video, sketch um, the image, and then continue on in the video. So let's go ahead and get started, and let's first just kind of define what is a chemical reaction. And so we started again talking about this a little bit in class, but specifically a chemical reaction is going to be a process in which one or more reactants undergo a chemical change and form one or more new products. And again, we've talked about this a little bit in class thus far, but again, using these terms like reactants and products, you do want to make sure to note that, again, reactants are going to be anything that falls to the left-hand side of the arrow, and anything that falls to the right-hand side of the arrow is considered a product. Okay, great. So reactants are literally the substances that are going to undergo the reaction, and the products are literally the substances being produced. If you understand those two terms, it's not that difficult to remember. So let's go ahead and jump in and start talking about our different types of chemical reactions. Our first type of chemical reaction is one of the more basic types of chemical reaction. Okay, and as you can see from our little love story here, that we have two separate substances coming together to form one substance together. So in two single people coming together to form a couple. Okay, and so this type of reaction is called a synthesis reaction. Okay, so synthesis reaction. And it follows the general formula of A plus B becomes AB. Okay, so again, if we're going to describe this reaction, it's going to be two or more simple substances react to form one product. And so I want to be clear here, it doesn't have to be just element plus element becomes compound. You can also have an element plus a simple compound becoming a more complex compound. You could have element plus element becoming a compound. So as long as, I think like the easiest way to remember it is if you end up with just one substance on your product side, it's likely a synthesis reaction. Now, maybe you're familiar with Star Wars or maybe you're not, but in this instance, right, it's showing that coupling of Leia and Han Solo. However, when I like to tell this story, I like to tell it in the love story of Annie and Bob. And so Annie and Bob become a couple, okay? And let's talk about a real world example of a synthesis reaction. So our synthesis reactions that we can use, okay, or that we should be familiar with, or one that's very easy, I guess, to use, or to I can't speak today, to be familiar with as an example would be the synthesis of water. And we talked about this in class, but that's going to be H2 plus O2 becomes, okay, H2O And again, obviously this is unbalanced, so we would need those coefficients of 2 and 2. Okay, but this represents synthesis. We have our simple substance H2, our simple substance O2 coming together to form our complex substance H2O. And again, identifying it is easiest because we have one product in this reaction. Okay, let's go ahead and take a look at our second example of a second type of reaction. Okay, so opposite to our reaction of synthesis, you'll notice here that we have the flip switch, okay, which is going to be that breakup of a couple. And so here you can see that our couple has split apart and is two separate entities. And this reaction is called decomposition. Decomposition, right? When things decompose, they break down. And our general formula for this is going to be AB becomes A plus B, okay? And our description is going to be one reactant splits into two or more products. And again, an easy way to kind of identify a decomposition is just by noticing that you're starting with only one substance and it's breaking apart into more than one substance, okay? An example of this, I gave you, right, on the previous, on synthesis, I talked a little bit about how it doesn't have to be compound or element becomes compound. It could be element compound becomes more complex compound. So I think for this example, I want to show you that. So here we have KClO3, okay? And in this compound, when it decomposes, it produces KCl and it also produces O2, okay? And I ran out of room here, so I'm just gonna write it on the bottom. So here you can see we have a more complex compound. This compound contains a polyatomic ion, and it's decomposing to form potassium chloride, a simple compound, a binary compound, and an element which is just oxygen. Obviously, this is unbalanced. You do want to always make sure your reactions are balanced. Okay, but that's going to be our decomposition reaction. Okay, let's go ahead and take a look at our next type of reaction. Okay, in this reaction, especially from our sketch, you can see that we have a couple and that couple swaps partners and we end up with the opposite person single, okay? So I always like to tell this story in terms of like, okay, imagine going to the dance with somebody and then you decide you no longer like that person and then you leave the dance with somebody else, okay? Kind of a crazy situation, but it happens out there. And so we had here, okay, Han Solo swapping spots with, I'm guessing that's Luke, right? I do know the Star Wars films, but it seems a little weird. I guess Luke and Leia, brother and sister, just leaving as like a nice escort, and then Han Solo by himself, okay? So this is called a single replacement reaction. And it is where we are replacing just one of the substances in the compound. Our general formula is going to be AB plus C yields AC plus B. Again, notice that in this reaction here, okay, we have our B and our C swapping out and leaving A within the compound. Okay, there are two types of examples I want to give you, and I'll go through that in just a moment. Let's get our general descriptor down for this. And this is going to be a compound reacts with an element, okay, to form a new compound and a new element, okay? So we have to talk about two specific examples. And again, we'll dig a little bit deeper into this in another lesson. We're going to spend a whole day talking just about single replacement reactions. But there's two examples I want to give you. Okay, the first example is NaCl, okay, plus F2 becomes, okay, NaF plus Cl2. Okay, and the second example I want to give you is NaCl plus Li becomes LiCl plus Na. And what I want to specifically point out here in this example, let me grab a new color that's not something I've used before. Okay, what I want to point out here is that in our first reaction, the two atoms that switch, the Cl swaps with our F2 and becomes F and Cl2. Try to think, what do F and Cl2 have in common with one another? Okay, why do we see the F take the place of the Cl and not of the Na? Okay, and so what we have to note is that in this first instance, okay, the nonmetal, the Cl is a nonmetal, is replaced, okay, by F, which is also a nonmetal, okay? And so in that first reaction, F swaps spots with Cl because they're both nonmetals, right? And we don't need Cl and F to bond together, right? And then the Na would just be on its own singularly. So now let's take a look at the second reaction. And if you followed along on that first one, you might be in a good place for the second one. Okay, Na in this instance swaps with Li, right? Those two swap with each other. And now it becomes LiCl with Na on its own. So why does the Li swap with Na and not with Cl? Okay, again, the Na is replaced by the Li, which is a metal. So nonmetals replace nonmetals and metals replace metals, okay? So we'll talk a little bit more about that, but it is important to note that we are going to be swapping only of the same type of ion, okay? Let's continue on in our types of reactions. So here we have our fourth type of reaction, and here you can see we have two different couples becoming two different couples, okay? And so if the one couple swapping spots with one person is called single replacement, then this is going to be called double replacement, okay? And double replacement reactions, again, involve two compounds where we swap their partners. So kind of like if you've ever done square dancing in gym class, swing your partner do-si-do. I don't know, isn't there like a swap your partner do-si-do? I'm not sure. Okay, our general formula here is going to be AB plus CD becomes AD plus CB. Okay, and I am very purposeful of where those letters remain. Notice that A was always in the front, C was always in the front. Again, when we're writing compounds, we typically write the metals or the cations first. And so we only ever want cations to bond with anions. Okay, so in this example, we have two compounds swapping ions to form two new compounds. Okay, swapping ions to form two new compounds. An example of this, okay, we have AgNO3 plus NaCl. Now, before I just give you the products here, let's take a moment to think. Who's going to swap with who? Remember, we only want cations to bond with anions. So who's going to swap their partners here? Okay, well, Ag is a cation and Na is a cation, which means that Ag and Na are not going to bond together. So I like to do this by pushing arrows to help me remember who is bonding with whom. Okay, and you do need to remember to always double check those charges as well, just to think about what ratio will my new compounds bond in. But again, we're going to do a whole practice day on maybe double replacement predicting products, so I'm not going to focus on it just yet. But we would end up here with, okay, Ag now bonding with Na's former partner, the Cl, and Na bonding with Ag's former partner, NaNO3. Okay, awesome. One last type of reaction here. So if we look and we scroll down, we have one last type of reaction. It is the one that always stands out. It has no real, I don't want to say no real purpose, or it just doesn't fit the general mold of all of the reactions that we've looked at before. And this reaction is called combustion. Okay, and when you hear that term combustion, that usually to me indicates, right, something's blowing up or there's fire, combusting. Okay, and so the combustion reactions really generally follow two general reaction formats. We have CXHY, and I'm using X and Y in the place of any numerical value here, reacts with O2, okay, and it's going to form CO2 and H2O. And we have CXHYOZ, again, X, Y, and Z being any numerical value, plus O2 becomes CO2 and H2O. Now, something that I want to just take a moment to point out here, okay, both of these, in order for it to be considered combustion, have to have oxygen as a reaction or as a reactant. Okay, so oxygen reacts with an organic compound, and an organic compound being these CXHY, CXHYO-Z compounds to produce CO2 and H2O. And that's the other defining thing, right? Both of these produce CO2 and H2O, and that's our combustion reaction. To give you an example, CH4 reacts with O2. CH4 is methane, okay, and that's going to be, if we ever get back to school, the kind of gas that's in those Bunsen burners, reacts with oxygen to produce, guess what, CO2 and H2O, okay? At the bottom of this guided notes sheet, or what I'm going to do is I'm going to just pop this on the screen for just a moment. I'd like you guys to go ahead and identify these types of reactions. Okay, classify them. Are they synthesis, decomposition, single replacement, or double replacement? So go ahead and pause the video, take a moment, and determine the types of reactions. Okay, so welcome back. Let's go ahead and go over that. In our first reaction, we have an compound plus an element producing a compound plus an element. And if you think back to our types of reactions, notice that the Br swaps places with Cl and the produces the NaBr and Cl2. This is considered a single replacement reaction. Okay. Second question, we have elemental Mg combining with elemental oxygen to produce one singular compound. This is a synthesis reaction. Okay, we have in number 3, NgSO4, a compound, reacting with AgCl, a compound, producing Ag2SO4, a compound, and MgCl2, a compound. And notice that the Mg swapped places with Ag, okay? And so this would be a double replacement reaction. And last but not least, we have NH3. This is a compound breaking down into elemental nitrogen and elemental hydrogen, and we end up with a decomposition. All right, everybody. I hope you guys had a great time learning about types of reactions, and I will see you guys in class tomorrow. Have a good rest of your day.